Hi everyone and welcome to today's webinar, Object Storage for HPC Data Sets. Before we begin, I want to get a few housekeeping items off the table here. Please feel free to ask questions throughout. We like to have an informal webinar. We like to make it conversational. We also have a number of great attachments for this webinar. We have a few website links, some solutions briefs, specifically a solutions brief with one of our partners, Globus. So please check those out either during the webinar, after the webinar. If you have any questions on any of the briefs or any of the content, please let us know. And with that, let's go ahead and get started. Some introductions are in order. My name is Adrian Herr. I'm the VP of Marketing. I will be your moderator today. But the star of the show, as always, with our Tech Tuesday webinars is John Bell. John, would you like to introduce yourself?
Certainly. Thanks. So I've been with Caringo for a little over 8 years, and I've had the privilege and opportunity in the field for our customers, specifically for our customers that are using it to solve the issues that they encounter when manipulating high-performance computing data sets. So this is right up our alley today, Adrian.
Yeah, absolutely, and that's a good segue to Caringo, our overview slide. We have over 500 deployments in those organizations. Tech, you see STFC down there that's associated with Rutherford Appleton Labs. You see a few other large organizations like the Department of Defense. So we have a lot of experience with HPC data sets, research data sets, and distributed environments. And why don't you walk people through what you're going to cover today, John?
Sure. Thank you, Adrian. So our basic categories that we're going to walk through today as we go through the presentation are as follows. We're going to spend a little bit of time on identifying what amounts to high-performance computing storage requirements and some of the pain points that are associated with those storage requirements, specifically pain points that a customer may encounter when trying to meet those requirements with what amount approaches. We're going to demonstrate how we bring a cloud approach to high-performance computing storage to address some of those requirements and eliminate some of the pain points, that we outline. How that cloud approach can be used to address HPC workflows, and then ultimately we bring it all together to show how the whole life cycle for data for HPC can be managed with a object storage solution. So to that end, let's dive right into it. So what are some of the HPC storage requirements and associated pain points that go with them? And we've worked a lot with a lot of our HPC customers and identified these over time. And the ones that are typically encountered for requirements are they need to be able to handle a very large number of files. And we're not talking about millions. We're talking about billions of files within their environment. On top of that, they need to be able to provide to their researchers parallelized access to that large number of files that they need to manage. They need to be able to demonstrate data integrity. This is scientific data. You need to make sure that, not only the raw data sets, but the result sets that are generated from them are kept in the system with integrity over to publish this data by various mechanisms, be it through your API, a RESTful API, Amazon S3, and so on. And we'll go through that as we go through the slides. Associated with that, they need to be able to provide multi-tenancy features with access to that data. They need to make sure that only certain users or groups are allowed access or to perform certain operations on certain data sets that reside within the storage system. And along with that, there goes the billing, quoting, quota accounting mechanisms that go with that. It needs to be web accessible, and it needs to be made easily web accessible. You can build a multi-tier architecture that ultimately publishes your data in a web format. That could be pretty hard to or system or network administrator. And it can be hard to scale over time. And one of the things that we try to do is meet that requirement and make it easy to manage that requirement. And then last but not least, they need to be able to operate on subsets of data locally. And that falls into the capability of being able to distribute these data sets or distribute this content, geographically, either entire sets from, say, a primary to a DR site, or just subsets from a main repository to satellite locations where people may be doing research locally and need to interact with it in that fashion. So what are some of the pain points that your typical HPC storage solution provider runs into when attempting to address those needs with traditional filers? You'll find that file systems can be difficult to scale against the billion of file and parallel access requirements, especially the billions of files. You run into the typical issues such as inode restrictions and so on when you're dealing with very large numbers of files or objects. You typically find a bottleneck at the storage controllers when it comes to parallel access. And what we find in practice is that bottleneck invariably is a network bottleneck. If you're trying to publish this content or interact with this content across a very wide population of people that are using it simultaneously, it's typically the network that's the bottleneck in that scenario. You may find the need to maintain multiple backups and copies of this data, and you can only go so far with tape backup and traditional filers and, say, snapshots. In that case, there are limitations to that. The files typically end up in separate silos. You may have a set of data that resides in a storage system at point A and another set of data that resides at point B, and they don't have the glue logic that's necessary for those two to share the information between the two locations or the storage, and things get siloed and get harder to access. Typically, when you're dealing with traditional storage, it has a focus on single-tenant applications and databases, and that typically means that your authentication, authorization, accounting, and access is all handled, through, say, a database check or a single applications check for looking at what a user or group is allowed to do, and that typically those access credentials are not shared globally. Sharing will typically strain DevOps and IT personnel. We've kind of touched on that already. Being able to publish this data in multiple formats and using traditional storage to do that means that you have, this large number of application and web layers that you may need to build on top of it in order to present it in that fashion, and that can be very difficult to manage. And then finally, there's the issue of metadata, and a lot of times when you're storing HPC data sets, being able to search on and collate data based on the characteristics of what was stored is just as important, if not more important, than the actual raw data itself. Being able to pull together exactly the things that you want to work on based on the characteristics that you tagged it with when you stored it is very important in the HPC world. But typically that metadata in traditional solutions is trapped in a separate database somewhere. And that leads again to yet another bottleneck when trying to perform list and query based on metadata characteristics. And it also presents issues where you want to build up collections or live queries of data sets based on those characteristics. And we'll touch on that a little bit further as we go through the presentation. But those are the major pain points that your traditional storage solutions run into pretty quickly when dealing with this volume of data. So how does object storage address those needs? First and foremost, it provides a global unified namespace. Now, what does that mean? That means that you can access this data, be it through a Swarm NFS connector, for example, in our product, Swarm NFS. You can access it with an NFS endpoint. You can access it with RESTful API calls, such as native calls using our API. You can access it with Amazon S3. You can access it with SMB and so on. And you know that whichever avenue you go through to access that data, you're going to be accessing it basically by the same name no matter which way you go. It's going to have the same name no matter which avenue you take to access the data. And that's what we mean by a global unified namespace. It allows for you, like I said earlier, to locate data based on its characteristics or metadata versus searching on things by what path it may be stored in, and having to depend on naming conventions for paths and whatnot, which may change out from underneath you over time. And you don't want that to happen. Being able to have that metadata locked in place and search on characteristics is incredibly important. We get by the file system limitations with things such as block sizes and inodes and things of that nature. We don't worry about that in the object storage world. We'll basically be able to store as much as there is physical memory to map what's on the volumes. There really is no limitation to the amount that we can store on the volumes. We offer a scale up and scale out capacity on demand. If you have an initial footprint of storage and you're starting to drop a lot of research data into it and it's building up rapidly, it's very easy for an administrator to simply boot up and drop in another server into the storage cluster, and then that capacity becomes immediately available for use. And there's no downtime required for that. There's no maintenance window that's going to has to be announced for that. You just boot up the system, drop it in, the cluster recognizes it as joining the cluster, and it starts making that space available to drop data into place. We talked about the global unified namespace and multi-protocol, multi-tenant access, be it by S3 or NFS. And we're finding in the field that a lot of this is starting to move towards S3. And it's very important, of course, that your S3 implementation, to be sure your object storage solution provides a strong multi-tenant approach to S3 access, and ours does that.
Yeah, and I guess one thing to point out there, John, is go on any college campus and see how many classes there are on file system protocols. Mm-hmm. And also take a look at the curriculum for cloud and RESTful interfaces. And you'll start to see where the trend is going and where the knowledge is going. The kids out there, the students, a lot of times the people working on these projects, all they know are RESTful interfaces these days. They don't know a lot of the traditional protocols that these silos are accessible from. So that's right. We're seeing that as a really requirement that's definitely moving up in importance.
Yeah, and that's a reflection of the philosophy that's behind that, Adrian. When you're coming up through the ranks in college, as it were, it's a collaboration environment, and RESTful access lends itself very well to on-demand collaborative interaction when working with data, and that's why we're seeing that big push towards using S3 as the protocol of choice for managing these data sets. That's a great point, Adrian. I'm glad you brought that up. Naturally, when you're dealing with objects, you want to make sure that the metadata and data not only are combined together. What that means is that an object is actually its content. The PDF, the spreadsheet, the raw data from a sensor, for example, that may be coming in and stored in the system, but also the metadata, the characteristics that are stored with it. Who's the author of it, when was it created, what project is this associated with, which sensor did this come off of, that type of thing. That's what we're talking about with metadata. You want that to be combined together and managed as a single object for a couple of reasons. One, it allows for highly parallelized access to metadata characteristics for list and query, because all of the storage system, all of the systems in the storage cluster are participating in those list and query activities. And secondly, it makes sure that your metadata is protected in the same fashion. as the actual content itself. You don't have to worry about some separate database out there being available in order to perform those type of operations. It's already present within the system and is protected within the system. But which leads to bit rot. You want to make sure that you are checking for and correcting bit rot automatically. This isn't something that you want to have to find out about after the fact, and it's certainly not something when you're dealing with billions upon billions of objects that you want to have to do manually. You want that system to be constantly doing this for you. And in the case of Swarm, we have a health processor that does that. It's constantly checking the integrity of the objects within the system and making sure that they're not rotting out from underneath you. You want to be able to provide flexible data protection schemes, and this goes towards tuning the efficiency of the storage versus the type of things that you're storing in the system. For example, for a very large number of small files, you may want to choose a protection scheme that performs the best by just doing simple replication, because it's a very large number of small objects, and simple replication, lends itself to that use case. You may have a large number of files that are gigabytes or even terabytes in size, and you don't want to do copies of that in the system with replication. You want to store that with a scheme that provides the same integrity but a lower footprint, such as erasure coding, with a data and parity scheme that can accommodate that. That's what we're talking about there when we're talking about flexible data protection. And specifically, you want to be able to provide the ability to support those multiple protection schemes all at the same time in the same storage cluster. And again, that touches on improved storage efficiency. You're not just doing only copies. You're actually able to tune for the actual raw and logical footprint of what you store in the system with object storage. Okay. So where does object storage typically live in a high-performance computing data workflow? Typically, it's going to live at the base of this pyramid, what I like to call the cost and performance pyramid. At the top, you have a very high-speed but expensive storage that's used for doing computation and manipulation on data sets, and then quickly being able to generate results from those data sets, because you're hitting that in a block-like fashion. You want that to be as fast as possible. And from there, you may go down to the next tier where you're using a clustered file system like Lustre, for example, or you're using perhaps a group of filers or a storage area network for that purpose. You're kind of still in the block and filer world here, but you don't have the capability to store billions upon billions of objects, and specifically billions upon billions of what amounts to unstructured data, and that's where the object store comes into play. And Adrian, I'd say it's fair to say, based on our research, the vast majority of data that is managed in the HPC world falls in that object storage. It's even maybe perhaps a group of result sets that are generated from those raw sets. They don't change very often. The applications don't interact with them directly, but they're very important to have for people to be able to pull and review and attempt to do things like, recreate the results.
Yeah, and that's one thing looking at this pyramid that doesn't really come out. It's the access requirement for the object layer. Object is really all about access, all about continued access. Whereas you go up that pyramid, it's more about analysis and just overall speed of capture. More your scratch space. The device is writing to these flash drives because they're creating such large data sets and at high resolution.
Yeah. It's almost like we need another arrow that deals with the aspects of parallelized read access, which if you think about it, that's the vast majority of what happens in the research world. Is a lot of people want to be able to get things on read. They may not necessarily be doing a lot of generations with write. And when it comes to reads and publication to large populations, that's where object storage really shines.
Yeah, and that's where we find one of the big pain points in HPC workflows is providing the easy to manage distributed access to those data sets in a way that's manageable from the server side, where you don't have to give credentials out and then have to manually manage those credentials. We see that as still a very large issue across research organizations.
Mm-hmm.
So we still see organizations managing credentials and authentication authorization on spreadsheets, for instance, or providing access to data sets, moving them into FTP servers. And we still see those kind of workflows going on in research organizations.
Mm-hmm. In fact, that would be an additional pain point, is being able to provide self-management of access.
Absolutely.
Yeah, very good. Okay. So that leads to this end here. Swarm does shine for groups that access billions of files. And basically what we have outlined here is an example of that, where you would have, say, billions of objects in a Swarm object store. And the Swarm object store has been set up for multi-tenant access. And there's a group of data. It could be videos, it could be satellite data, photographs, it could be audio, it could be documents, it could be IoT raw sensor data, you name it. It's all stored in the Swarm cluster and set up with multi-tenancy in mind. The writes that are coming in from those various sources could be going into different storage domains that have been outlined in the system. And depending on, which data is of importance to you, you would be set up to be allowed to have access to that subset of data. Or you'd be able to do list and query or build up what we call dynamic folders or collections based on the characteristics that you're interested in that data has been tagged with. And we're just showing there, you could be at an office in multiple geographic locations, and based on the things that are of interest to you, based on your list and query that you've submitted to the system, you're going to get back a result set that's basically presented to you in a folder or bucket-like fashion. And that's the real power to all of this, is this dynamic list and query. These dynamic queries or collections that allow, so as new data is dropped in with those characteristics, it's always going to show up in that dynamic query that you've set up. You'll always see it as it comes in, and always be up to date. You won't have to worry about missing anything new that comes in. Okay, which leads, of course, to our cloud approach to high performance computing. What do we mean by that when we say that? We want to be able to consolidate all of this research data in a single storage solution, and then turn around and secure that with multi-tenant features that allow for you to set up the level of collaboration that can be allowed amongst the users and groups that are participating in the system. We provide that support for search and custom metadata collections for analysis, and then we can surface that via multiple protocols for next generation applications and workflows, such as Swarm NFS, API personality, the S3 API personality, and so on.
And if I can throw one more word onto this slide, it would have been private cloud approach, enabling research organizations to really act as their own cloud service provider to their students, to their employees, or really to anyone that needs to access the data sets that they control.
Right. To your original point, that's the type of technology, that's the type of interaction that people that are pushing the boundaries of the field are used to working with, and they may hit a situation where, say, they can't use an Amazon S3. Or they can't use a Dropbox or Box or whatever, but they still want to be able to use those tools that have been built along those lines for the work that they're attempting to do. And what we do is we allow for that to happen by being able to build an in-house cloud solution that takes advantage of that vast constellation of S3 clients, for example, that exist in the world today. and not have to change the way that you interact with the data as a result.
Yep. There's no getting around speed of light when you're talking about data transfer, right? So it's better to keep it within the network. It's always going to be your fastest option.
Right, and to go back to the previous slide, we'll touch on locality here in a little bit, but that's another thing that we're trying to demonstrate here too, is locality through replication. We'll go into that in a little more detail in a little bit. Okay, so let's dive into the details behind multi-tenant management within the Swarm object storage solution. So what we do is we have the capability to connect to authentication stores such as LDAP, Active Directory, or basically anything that's supported by Linux PAM or pluggable authentication modules. And we also provide a token-based authentication as well. We allow for users to set up tokens, especially in the case of the S3 protocol personality. They can set up S3 tokens to configure their applications to interact with the storage in that fashion. The administration of the storage itself is done with a RESTful API and is done by web portal as demonstrated by the pictures. We can provide for a flexible naming scheme. There are no bucket limits. For example, if you're used to working with Amazon S3, you may find that there's a bucket name that you want, but you can't get because it's already taken. You won't have that limitation with our system. You can have multiple buckets of the same name that reside in different domains within the system. You could just use your own domain as a result, even set up vanity domains for projects. And of course, when it comes to interoperability, you can operate with it by HTTP 1.1, S3, Hadoop file system, NFS, and SMB, as we mentioned previously. We've got a question here, Adrian. I think I can tackle this one right now.
Yep.
Yeah.
John,
go ahead.
We'll read it out. So the question is, what other technologies does Swarm work with? Who are some of your HPC technology partners?
Well, what other technologies does Swarm work with? But basically, I kind of touched on that earlier. A very simple example of that would be any application that's written to use S3 as a storage backend. And there's a large number of those. There are backup solutions that do that. There are data tiering applications that do that. Publication platforms that do that, like in media and entertainment, and so on. It's a pretty large number, so I can't really go through them specifically, but anything that interacts with S3 is a perfect example of something that would work with Swarm. And there are native integrations as well, but what we find is the vast majority of people like working with the S3 API, and that's why we provide it. As for a good example of some of our HPC technology partners, a great example of that would be Globus. For those of you who are not familiar with Globus, Globus is a research data management platform. It is a University of Chicago nonprofit service. I believe that's right. Is that correct, Adrian?
Yes, that's correct.
Yeah, that's right. And basically what they do is they provide a platform for research data transfer, share, and even ingest and build. And the way that they're able to interact with our storage solution is quite naturally through Globus's S3 connector. That's how it works. So they plug right in, and it works really well as a result. So if you can interact with things out in the cloud with Globus, you can interact with localized storage, for locality and performance using our S3 solution with Globus and so on. I'd say that's a great example of an HPC partner that we have in the field.
Yeah, absolutely. And on the workflow slides, I think you can kind of point out where Globus would plug in, I think, just to drive home the point.
Sure. Okay, which leads to our multi-tenant workflow bullet here. And as we mentioned previously, data sources can come in from various locations of various type. It can be experiment data, it could be raw data, it could be IoT sensors and so on. Optionally, it may or may not go through some kind of compute service where some initial analysis is done on it. It may go through, maybe it goes through a data transform of some kind. So you have the raw and the data transform that it goes through. And then typically that's dropped into primary storage. And you may do some secondary compute on it or whatnot. And ultimately what you end up with is you end up with a set of raw data and a set and a result set or result sets that are associated with it. And you don't want that sitting on your most expensive storage. I don't know why it keeps doing that, Adrian.
Yeah, I'm not sure either.
Yeah, anyway, I'll be quick. You typically, to free up the space on your primary storage, you're going to tier this out either to an S3 or an NFS target. And that's what Swarm can provide. It can provide either one of those targets. And it'll drop into a multi-tenant storage archive. And depending on how you move things, it may reside in different domains with different access credentials associated with it. And you may choose to publish that as read-only to the cloud, and you can do this straight out of Swarm. You don't have to have specialized application and web tiers to do that. You can do it straight out of Swarm directly. Or you may decide to replicate it to a disaster recovery site, or it might not be for DR. It might be a remote collaboration site, and they need localized access to that data, and you're able to do that as well. Well, since Bright Talk insists on moving me to this slide, we'll talk about this one. So how does Swarm manage unpredictability in HPC workflows? We kind of touched on that in the previous slide, but let's go into it in more detail. Again, you can have data coming in from multiple avenues. It could be coming in from an HPC compute cluster. It could be something that's tiered off of a Lustre or cluster file system. It could be individual instruments or devices that you need to take data from and ingest, user home directories, Hadoop, you name it. The whole goal of this is to unify the storage and as a result, reduce the primary storage footprint and associated costs for your experimentation space and increase the overall availability of the storage space that is there for that purpose. And by taking this multi-protocol access approach, this cloud approach or services approach, you can easily adapt to the requirements of these various avenues of ingest that are coming in. You can scale up and scale out over time without any downtime as a result. So it's always up, it's always there, always up, always available is what I like to call it, Adrian. People they may even want to look at it from their phone and they have the capability of doing that with this solution. Yeah, it streamlines, streamlining your access to different groups, to different applications, to be it laptops, tablets, phones, PCs. It doesn't matter. It's all accessible in one location by using this method.
And you hear this term thrown around a lot, future-proof, right? And
right.
I'm not a fan of the term, but really object storage does make data access future-proof. Supporting both traditional and the new RESTful interface access. And it just, as you mentioned, it just streamlines access. So I guess in a way it does make your data future-proof. There needs to be a better way to say that, right? Maybe you can think of a better way, John.
Well, I think it goes back, we wrote a blog on this recently. We talked about the 3 V's of big data. And one of those, the 3 V's are volume, variety, and velocity. And this plays to the second V, which is variety. You need to be able to provide a variety of methods for being able to access and manipulate these HPC data sets. And that's what we're demonstrating here in this slide, is the variety aspect of it. Certainly volume and velocity play as well. Velocity, billions upon billions of things that need to be stored with volume. But here the most important part is the variety of access that is provided. Access from anywhere on anything at any time, I would say, is what's being best demonstrated here.
Yeah, absolutely. And you mentioned the approach and the NoSQL, and you also don't know what you're going to need to access. So you have both the device and the actual point of consumption from a device perspective, And the fact that you don't need to go ahead and specify your tables and the data that you're collecting, you just kind of all dump it into metadata and you take a NoSQL approach to analyzing that at a later date. So, object storage is really combining the best of both worlds there.
Yeah, the unified namespace can't be emphasized enough in importance when it comes to being able to solve this problem. You really need to have that. You can't have siloed namespaces and solve this problem. Which leads to our next slide. So universal access from global namespace, we've touched on this a little bit more, so let's kind of walk through it. We're talking about the simultaneous access by either native API, in the case of Swarm, it's SCSP or Simple Content Storage Protocol based on HTTP 8.1. Basically you're just making web calls to it directly. It's a RESTful interface. Another RESTful interface would be Amazon S3, very similar in nature. Or you may be accessing this through protocol plugins such as NFS with Swarm NFS, or with HDFS with our implementation of HDFS connection. You'll find that we do our very best in the case of S3 to be as close to 100% Amazon S3 compatible as we possibly can. We use Amazon's libraries to do this testing. We use their confirmation suites to do this testing and so on. In fact, it's become a bit of a challenge anymore to find something that's not compatible. And usually when it's not compatible, it's to your advantage. It's overcoming a limitation that you may encounter in Amazon itself. I mentioned earlier about not being able to get the bucket that you want because it's already taken. We actually solve that problem. So in this case, it's a very good thing to be using our implementation of S3. I would think you have much more flexibility in that regard. We do have the native Hadoop HDFS support for big data workflows that depend on that, and underpinning all of this, of course. When it comes to highly parallelized access, are stateless gateways, a scale out for client access for throughput and availability, and of course scale up, scale out in the storage cluster itself. And being able to manage all of these requests coming in, check the authentication, authorization, and access credentials against it, and so on, in a very high performance and scalable fashion. And what this does is it ultimately provides you with a bridge between traditional and modern applications, and gives you the cloud enablement that aligns with our approach. Okay. And again, of course, we show a similar HPC Tier 2 or active archive workflow. In this case, the flow is very similar on the left-hand side. But when you go to the Tier 2 or active archive, you may instead decide to push that out to tape. I don't know why it does that.
There's a 24-second autoplay. That's why it's doing that.
Oh, okay.
So it's just on those workflow slides. So if you go back every 24 seconds, it'll go ahead and move it forward.
Okay. Well, then I'll be quick about this. This is just a very similar demonstration of how the workflow could go, not just into remote site storage, but it could go into LTO tape as well. There's really not much difference between the previous one other than the HSM component that's shown here. Oops, 24 seconds. So bringing it all together, the life cycle of HPC data within the object storage solution. First and foremost, you're consolidating that data and you're eliminating data silos that may reside within your organization or within your research group, and putting it all into a single storage access point. And then from there, you're able to optimize acquisition and compute storage capacity, using the scale up, scale out features that we bring to bear in our solution. Collaboration can be easily set up and easily protected as well with secure and metered access with our multi-tenancy support. And then finally, the analyze phase with integrated search, with being able to pull up things based off their metadata characteristics and set up collections in that fashion. eliminates a lot of having to pull things out, working on it locally and then putting it back in. You can just do that collection and analysis work on the fly as is within the storage system itself. Well, Adrian, that's all we had for today. I'll let you go ahead and close us out.
Yeah, so we'll open it up for questions if there are any. I know we got some questions throughout. If you're watching the recording, please feel free, if you have questions, to email us at info@caringo.com. Just go ahead and reference the webinar that you're viewing, and we will get back to you as quickly as possible. Again, I want to point out the number of great attachments we have. We have links to our website that go over some object storage performance benchmark reports that we've done. These are actually based on real deployments at one of our customers' facilities, STFC. We have a lot of great information on the solutions brief for securely accessible multi-tenant storage for HPC workloads. We also have a great brief that goes over the integration with Globus and how to plug into their platform for authentication, authorization, and everything else that they do. And I don't see any questions, and I know we're coming up to the time limit here. So with that, John, as always, thank you very much. It was very informational. Do you have any closing statements?
None. Thanks, everybody, for joining us today. We appreciate it, and coming up November 12th will be our next Tech Tuesday. And the topic for discussion then will be object storage capacity planning for 2020 and beyond. And we also want to remind everybody to feel free to visit us at our SC19 or Supercomputing 19 booth, booth number 2249, if you get the chance to go to SC19 this year.
Yeah, absolutely. And if you're in the UK, we will also be at the CIUK STFC event with one of our partners, NAS. So if you are interested in meeting there, just go ahead and send an email to info@caringo.com or just go to our website and fill out the contact us form, and we'll get that routed over to the appropriate staff in the UK. And with that, once again, John, thank you. And we would like to thank everyone for taking the time and listening. So thanks, everyone. Thanks, John.
Bye-bye.